Well, hi there, everybody. We are back at it again. Remember, we have left trig behind, and we're now moving through our last 2 units of the year, and we are going back to an emphasis on algebra. So one of the big takeaways that you should have coming out of advanced math class is a way to solve algebraic systems. Now, a system of equations is usually joined together by a bracket, and then it has two or sometimes three or more equations. Oops, I copied that wrong. There we go. That have an answer in common. All right, so there's an equation. That would be a parabola because it's got a square. And then here's another equation. And these two equations have some answers in common with each other. And there's different ways that you could use to solve these systems. So we're going to talk about three of those different methods today, starting with method number one. So method one is substitution. And substitution is when you pick a variable and you isolate that variable. And so looking at the equation above, there is a single variable that is probably easier to get alone than any of the other ones. And I'm looking at probably either one of the two y's, but probably this y right there. So what I would do is I would add y to both sides. Now that doesn't give me y completely alone, but it gives me y on the right side. And I'd probably also add 1 to both sides. And I'd manipulate that equation so that I would have 2x plus 1 instead of 2x minus y, and then equal to y. So isolating one variable, picking a variable, moving it around, doing math on both sides, and getting it by itself. Now what I'm going to do with that is I'm going to take what I just got alone and I'm going to drop it into the opposite equation in the position where I had y. So the math on that is x squared plus 4x minus, and you always put parentheses about what you drop in, and I am dropping in 2x plus 1. And then that will be equal to the number 7. From there, you're going to do legal math to solve for the solution for the value of x. So the first legal step I want to do is I want to distribute that particular x, right, subtraction. So I'll have x squared plus 4x, subtract 2x, subtract 1, equals 7. Now, one of the big takeaways you should have from this year is how to solve a problem that has a square in it like this. Squared problems always need to be set equal to 0. So we'll take x squared and we will simplify this. So we'll combine the like terms, and I'll also subtract 7 from both sides. And that will give me minus 8. Now here's a perfect example for me to be able to apply factoring. So the top of my star factoring should be 8, the bottom should be 2. That should work out to be 4 and negative 2. So I take my 4 and my negative 2, I put 4 here, add an x to it. Then I take negative 2 and I add an x to it, subtract 8, set it equal to 0, and I'm ready to split that down the center. What's common is x, that will give me x plus 4. On the other side, what's common is negative 2. That will also leave me with x plus 4. Remember, that has to be identical on both sides. So I end up with x plus 4 as one factor and x minus 2 as the other. And that problem is equal to 0. So each term, each factor is set equal to 0 by itself. And we end up with actually two solutions for x. We get negative 4 and we get positive 2. So that means this system, these two equations, had two x values in common. They also have two y values in common. So what you're going to do with each of these x's is take each one of them and plug it back in to the original variable that you isolated. And you're going to do that twice, because you need to find the y value that goes with each x value. So this would be y equal to, now isolated was 2x plus 1, So this would be 2 times negative 4 plus 1. So y is equal to negative 8 plus 1, which means y is equal to negative 7. For the other x value, when I isolated it, it was 2x plus 1, so that's 2 times 2 plus 1, or 4 plus 1, or 5. So I end up with what's called pairs. We have answer pairs or coordinate pairs. And what that means is negative 4 as an x value is paired with negative 7 on a y value. And 2 as an x value is paired with 5 as a y value. Now we put them in coordinate pairs because that leads to the next method. If something is a coordinate pair, it means it could also be solved with graphing. So this was one method, the substitution method. The second method is the graphing method. In the graphing method, you don't just get one y alone, you get both of them. So we want to isolate both y variables. And once you've isolated both y variables, then you can use the graphing method. So here's your example number 2. Your first example might be 3x plus 2y equals 6, followed by e to the y equals x minus 2. Now, in order to solve this with a graphing method, we are going to have to do math to both parts of these so that y is by itself. So let's look at it one at a time. Let's start with 3x plus 2y. What I'd want to do there is subtract 3x on both sides, and then ultimately divide by 2. So that will give me 2y equals 6 minus 3x. I want to divide all the parts of that by 2. So I want to divide this by 2 and the 6 and the negative 3. So that will give me y equals 6 divided by 2 is 3 minus 3 halves x. And that is called my y1. Now let's review how to do that with e to the y. If I want to get y by itself, I need to get rid of the e. Now there's only one thing that we have learned this year that gets rid of e, and that happens to be the natural log. And so I will need to use a natural log with parentheses on both sides. So what's going to happen there is when you use a natural log, the y pulls to the front. Remember that? I mean, we were doing that before Christmas time. So that leaves me with y to the front of the natural log of e, and on the other side, the natural log is around x minus 2. What happens here is that the natural log cancels out the e and leaves me with y by itself being equal to the natural log of x minus 2. And I call this my y2. Now the reason I call it y1 and y2 is because I'm going to use my graphing calculator to graph these two and come up with their intersection points, or the solutions that they have in common. Alright, so I've grabbed my graphing calculator, and in y1 I've entered 3 minus 3 halves x. Now remember, with a fraction you need to surround that with parentheses, so 3 halves is in its own parentheses, and then the natural log of x is also using parentheses around x minus 2. Now before I graph that, I need to double check my window, and because I was using my window to do trig last, it's all kind of messed up. So I need to make sure that I've set negative 10 to 10 with a scale of 1 in both the x and the y directions. So I want my x min and max to be negative 10 and 10. The last thing I want to do is check my mode and make sure that everything is highlighted in that left-hand side. Then I'm ready to graph, and I should see the line come down first, and then I can see where the natural log graph crosses it. So what I'm going to want to see on your paper for these is a sketch of the exact same graph that you see. Don't just list me the answers. I want to see a picture. It doesn't have to be perfect. It doesn't have to be on graph paper. It just needs to be a sketch of what you're seeing. And then we're going to find the intersection by doing second followed by trace. And that will give me the intersection point. Okay, so I'm going to move, if we go second trace will take me to the calculate. That'll give me intersection number 5. And I want to move my cursor down to the place where I see the intersection. All right, and I hit enter 3 times, 1, 2, 3. And I have the intersection. Please round to 3 decimal places. So 2.483, but I look at the 9, which means 2.484. And then y is 0 or negative 0.725. Look at the 8, that means 0.726. So on your answers, what I want to see then is a sketch of what you saw. Maybe a little bit lower, there we go. Okay, and then identify those values. So you would maybe put an arrow or something and say 2.484, comma, negative 0.726. Okay, so I just need a sketch of what it looked like overall. Okay, there is a second system. I'm going to practice with graphing. So I don't want you to just tune me out because you're like, oh yeah, I can do graphing. But I want you to see a second one. That's got x squared plus y squared equals 4. And also 3e to the x minus y equals 2. All right, so we need to get our y variables alone in this case. So let's look at the first one. The first thing I would do is to subtract x squared from both sides. So that would leave me with y squared equals 4 minus x squared. Now, in order to get y squared alone, I will need to use a square root on both sides, which does not mean separate square roots like that. Okay, that is fake math. When you apply a square root, you only get one, and it has to go over the whole thing. You also need to remember, in front of every square root goes a plus and minus. So what does that leave me with? So I am going to end up with y by itself, and I am going to end up with the square root of 4 minus x squared. Again, you can't simplify those and cancel out the square root with the 4 because of the subtraction. But I'm going to have 2 of these. I'm going to have the plus and I'm going to have the minus in 2 separate equations. Okay, the plus here, the minus there. This means y1 and y2. That's a common mistake, is for people to miss the second one of those. All right, for the next equation, I need to get the 3e to the x subtracted to the other side. Okay, that is going to leave me with negative y equals 2 minus 3e to the x. And I still need to get y by itself by dividing everything by negative 1, which will leave me with y by itself and negative 2 plus 3e to the x. Now this is going to be my y3 in my equation, so this one will have 3 separate equations instead of just 2. Let me show you how to do that on your calculator. All right, I'm about ready. Notice in my y1, I've put the square root of 4 minus x squared. In y2, I need to put negative. Now that's this button here. This is not subtraction. If you put subtraction, okay, if you use the minus key instead of the negative key, then you'll get an error, and it'll say, you know, that it can't graph it, and then you'll be very sad because I'm not there to help you with your calculator. So you got to do it yourself. Negative square root 4 minus x squared. And then the last one we had was negative 2 plus 3e to the x. All right, now double check my window. It should still be good from last time. Okay, and then I'm going to see the intersection. Now I'm going to see sort of a circular thing and then I'm going to see my exponential come across real flat, and then all of a sudden take a steep dive upwards, and we've got multiple intersection points here. All right, now the easiest way I think is for you to do two at a time. I'm going to recommend that for the time being, you go to your Y2 and you just unhighlight it using your Enter key. See how it changed from an equal sign? Now when I look at my graph, it's easier to find the intersection if I'm just doing two at a time. So I'm going to find that top intersection first. So I'm going to go to second calc, option number 5, and I'm going to find that intersection spot by hitting enter 3 times. And I'll record 0.282, look at the 6, it becomes a 3, and 1.979, look at that 9. Now that's an interesting rounding. I want to talk with you about what to do with that in just a minute. Okay, but I want to go back to my y equals, and I want to turn off my y1 by hitting the enter key, and I want to go down and turn my y2 on. Now that one's highlighted, and I want to take a look at that combination. So now I've got the lower half, and I'm going to be intersecting that. So I'll do my second trace. There we go, number 5. And I'll find the intersection of that one, hitting it 3 times. Okay, so let's write down what we've got now. Okay, so we're going to sketch our picture. Our picture had an upper semicircle and a lower semicircle, and then we had the exponential that came through and then shot up that way. Okay, this one right here, that was 0.283, comma, 1.9799. Okay, now what do we do with that when we want to round? Well, we're going to look at 799 here. Okay, if we're going to round, we don't just look at the 9 and how it affects the last 9 and how it affects this 9. You got to look at how it affects the 7 also. So look at all of them, and it's 799. Well, the next closest thing is 800. And so when we round this, it will be 9800, or just 980. Okay, this one down here didn't really take any special rounding. We can see that one's still in the picture. Negative 1.496, comma, negative 1.328. All right, there is one final method of solving these systems that we're going to talk about today, and that is the method of elimination. In elimination, you don't have to get any of the variables alone. So let's look at a system that's set up nicely for eliminating. And I would like to do 2x plus y equals 1 and negative x plus 2y equals 7. Now really, you can do any method you want, but as I look at this one, the method of elimination jumps out at me as something that might work well, because I notice right away that my x values, that one is positive and one is negative, and I can use that to my advantage. And what I want to do is I want to double all of the lower terms on the bottom row. So I'm going to multiply, let me show you why I will do that. I'm going to multiply by 2, multiply that by 2, and I multiply that by 2. What that will give me is a new system where the top row is unchanged, but the bottom row becomes negative 2x plus 4y equals 14. Now the reason I did that is now I can really use the positive and the negative to my advantage. Elimination means if I combine these two equations together, I will have eliminated the x's. Okay, so we're going to do a combination now where we group all of the like terms together. And when we group 2x and negative 2x, they cancel each other out. And when we group y and 4y together, we get 5y. And 1 and 14, we get 15. And then it becomes real clear to us when we do the math of dividing by 5 to both sides that y is equal to 3. So this is a real popular, slick way to do it. It works best when you have opposite sign variables in the like terms that you can use to your advantage to eliminate an entire variable. But you're not just finished there. You're going to have to resubstitute back into either one of your equations. So I'm going to take this value and I'm going to substitute it back into that single y variable right there. So I'll end up with 2x plus the y value now of 3 equals 1. And I'll be able to solve that by subtracting 3 on both sides. So 2x is negative 2, so x is negative 1. So we have the solution of negative 1 for x, and y is 3. Make sure you always list your x value first and your y value second. Okay, our very last example is one other elimination system. And what I want to look at with you, 3x minus 12y equals 8, and 4y minus x equals 1. Now, one thing I need you to notice about this elimination problem is that the second equation is out of order. So you do want to make sure that the variables are in the right order before you start trying to eliminate. So I would switch the order of the bottom equations, and I would have negative x plus 4y equals 1. And then I notice that I could use the x's to my advantage if I would multiply the bottom row by 3. And so I'll take that bottom row and I will multiply it all by 3. So that keeps the top equation the same, 3x minus 12y equals 8. And then the bottom equation would be negative 3x plus 12y equals 3. Okay, I just multiplied everything times 3, times 3, and times 3. Okay, now we're ready to eliminate. And so I look at those x terms and 3x and negative 3x. And then I look at the y's, and I notice that I get 0y equals 11. Now when I divide both sides by 0, y is 11 by 0. I can't divide something by 0. So that is no solution. Right, there is no solution to this equation. Okay, it's not possible that that works out that way. Okay, so this is not, there's nothing in common that this equation would be able to be solved with. All right, so watch out for that situation when it happens. Okay, I hope you guys, most of this should be familiar, that you worked through this before, but maybe the equations are a little bit more complicated than what you did in Algebra 2. And then we'll talk about how to apply these to word problems for our lesson tomorrow.